Hello everyone and welcome to our video devoted to UI development. Our session will focus on user interface development and platform-based application. We will learn more about the types of the screens, screen templates, and will create new screens using Studio screen templates. Moreover, we will discuss how to work with different types of data sources, describe validation options available in the platform, and the actions fine-tune. Also, we will cover the rules of screen layout and common mistakes of UI development. Generic user interface subsystem allows you to create UI screen using XML and Java. The screen created using this approach work identically in both standard client blocks, web client, and desktop client. Main components of generic UI screens are marked as green. XML descriptors are XML files containing information about data sources and screen layout. Controllers are Java classes containing logic for screen initialization and handling of events generated by UI controls. The code of application screen included in the GUI module interacts with visual components interfaces implemented separately in the web and desktop modules of the CUBA-based project. For web client, the implementation is based on the Vaadin framework, for desktop client on the Java Swing framework. Visual Component Library contains a large set of ready-to-use components. Data sources mechanism provides a unified interface that ensures functionation of data-aware visual components. Client's infrastructure includes main application window, mechanisms for display and interaction of UI screens, and means of interaction with middleware. Let's talk about screens in more details. The following basic types of screens are available in the platform. Simple screen. Simple screen enables displaying and editing of arbitrary information, including individual instances and list of entities. This screen type has only core functionality to display it in the application's main window, close it, and to work with data sources. Screen identifier in screens.xml file may have an arbitrary format. The controller of a simple screen should be inherited from the abstract window class. Lookup screen. When a lookup screen is invoked by openLookup method, it displays a panel at the bottom with the buttons designed to pass an instance of the currently selected entity to the calling code. That is the main difference between the lookup and simple screen. When being invoked by openWindow method, or for example from the main menu, the panel with the buttons is not displayed. Lookup screens are recommended to be used to display a list of entities. Visual components intended to display and edit links between entities, such as pick a field, lookup, pick a field, invoke lookup screens to find related entities. For standard action to work correctly, an identifier of a lookup screen in a screens.xml file should have the format of entity.lookup, for example, customers.lookup. The controller of a lookup screen should be inherited from the abstract lookup class. The lookup component attribute of the screen's XML should refer to the component, for example table, from which the selected entity instance should be taken as a result of the lookup. By default, Studio generates Entity Browser as an inheritor of abstract lookup. Edit screen. Edit screen is designed to display and edit entity instance. It initializes the instance being edited and support actions for committing changes to the database. Edit screen should be opened by the openEditor method, passing an entity instance as an argument. For standard action to work correctly, an identifier of an edit screen in screens.xml file should have the format of entityname.edit, for example, in customer.edit. The controller of an edit screen should be inherited from the abstract editor class. The data source attribute of the screen's XML should refer to a data source containing the edited entity instance. Frames. Frames are part of the screen intended to decomposing and reuse. The frame element of the screen's XML is used to add a frame to the screen. It defines either path to the frame's XML descriptor or its identifier if the frame is registered in the screens.xml file. A frame controller should be derived from the abstract frame class. Let's see this in an example. Open Shop Orders screen. Select any order and click Edit. You can see that the customer field is represented with the picky field component. Click the three dots button to open the customer lookup screen. As it was mentioned before, lookup screen has a panel at the bottom with the buttons Select and Cancel. Now let's open the same screen by invoking the main menu item. Open Shop Customers screen. We see that the customer browser doesn't have a panel at the bottom. Now let's see how screens can be created. Let's go to your studio. Open the Generic UI section, click the New button. Generic UI Templates dialog appears. Here we can see a list of the screen's templates. If you want to create a screen from the very beginning, choose Blank Screen Template. For an entity, you can choose between creation of two separate screens to read the list and create update an instance, or a single combined screen for all operations. To create a screen based on another screen, select the Extend an Existing Screen template. Specify the name of the screen that you want to extend in the Extend Screen field. The login window template is used to customize the original login window. There are three templates that help to create and customize the main window. The first template allows creating a standard main window screen provided by the platform. The main difference between two other templates and this one is that they provide a side menu on the left side of the screen. It can be responsive or not. Studio provides the ability to modify existing templates. Click Copy Template to create a copy of the selected template in the Studio Templates folder of your project. The copy will be opened in the template editor and you will be able to change it. Use the Edit and Delete buttons to manage templates located in the current project. To open the created screen in a designer immediately, click the Create and Open button. To stay in the templates list, click Create. Let's create the main window screen with the side menu. Select Side Menu Main Window template in the list of templates. Click Create, click Close. Now let's see how the modified main window looks in our application. We need to restart the application by invoking the Restart Application Server action. After the successful login, we can see the new main window. To introduce the visual interface editor of the Studio, we will extend the application's main screen so it will display stats for customers. Users will see the stats immediately after logging into the system. We have already extended the main window, so let's get it open and examine. Go to the Studio, select xmainwindow.xml file and click Edit. The main window is a special system screen. Identify it as a main window. The main screen controller should be inherited from abstract main window class. We are extending the platform main screen, so it has some components already. Side menu, full text search field, new window button, and app work area, and so on. The special app work area component is a workspace in which the application screens are opened. If CUBA Web App Window Mode application property value is set to the tabbed, which is by default, the tab sheet component with the application screens will be located on the workspace. Otherwise, the workspace will contain a single open screen. If no screens are opened, the workspace contains the components defined in the embedded initial layout element. We will place our stats table within initial layout so that it shows up when you log into the system, if no screens are opened. So remove the welcome label from it. The components library is located at the bottom right of the screen. There is a new set of components intended to edit the main window in the Palette tab. Let's drag the table component from the components library into the initial layout container. Our new component is highlighted on the canvas, and we can change its properties using the Properties tab. Let's set the table size so that it fills the entire available width and height. set the height to 100%, and set the width to 100%. To update table data manually, add a refresh button to initial layout. Drag and drop the button components from the library to the canvas. The space of initial layout has split in halves between buttons and table. In order to allocate more space for table, we need to set table ID to stats table and set the expand attribute in the initial layout to stats table. We will talk about the expand attribute later, as well as about layout rules. Let's now pass on the data level. Data source provides work of data-aware components. Visual components themselves do not access middleware and get entity instances from related data sources. Furthermore, one data source can work with multiple visual components if they need the same instance or set of instances. The dependency between the visual component and the data source manifests itself in the following ways. When the user changes the value in the component, the new value is set to the entity attribute in data source. When the entity attribute is modified in the code, the new value is set and displayed in the visual component. User input can be monitored both by the data source listener and the value listener of the component. They are fired sequentially. To read or write the value of an attribute in the application code, it is recommended to use the data source rather than component. Data sources also track changes in entity contained therein and can be sent modified instances back to the middleware for storing in the database. Now let's go back to the application. Go to the Data Source tab, click the New button. There are several types of data source. Let's see the main ones. Data source is a simple data source designed to work with one entity instance. Collection data source is a data source designed to work with a collection of entity instances. Value data sources enable execution of queries that return scalar values and aggregates. Value data sources work with entities of a special type named key-value entity. This entity can contain an arbitrary number of attributes which are defined at runtime. Typically, data sources are declared in the DS content section of a screen descriptor. For our stats table, we will use a value data source. Select the value collection data source as a type. Set the ID to customer stats DS. Let's move on to the queried attribute. This attribute specifies a GPQL request by which the records are retrieved from the database. And this query selects customer with the total amount of orders. Now click the Edit button opposite the Properties attribute. In the Properties dialog, click the Add button, set name to customer, set class to customer. Click the Add button, set name to sum, set data type to decimal, and click OK. Go back to the Layout tab. Select the Stats table and select the Customer Stats DS as the data source. Click OK to save the screen. Let's relog into the application. Our table has appeared in the main window. If we open any system screen, this screen will be hidden. Currently, the data is only updated when you open the app for the first time. Let us go back to the studio and open the XML window screen. Select the Refresh button. Specify the method name refresh data in the invoke attribute. Click the double brackets button. Click OK to save the screen. Click the IDEA button. The screen descriptor will be opened in IntelliJ IDEA. Switch to the controller by clicking the name of the controller class while holding Ctrl. In order to get access to the data source from the controller, let us inject it. Go to the Code section and select Generate. The IDEA will show you the context menu. Select Inject. Select the customer stats.ds from the injection dialog and click OK. The field marked with the inject annotation has been added to the controller. The value of this field will be injected when the screen is initialized. Let's move on to the refresh data method. Updating the data in the collection data source can be performed just by calling its refresh method. So we need to add the following code. Let's see how it works. Log into the system and create some new orders. Close the order browser and click Refresh button. The order list has been updated. Now let's see another example of data source usage. Open the Shop Orders screen. Click Create. We see that we need to open a lookup screen to select a customer. Let's make this action more convenient. Go to Studio, select Order Edit XML file, click Edit. Go to the Data Source tab and click New. Another example of using a collection data source is using as an optional data source for components like lookup field, lookup picker field, and so on. So you will have an ability to select related entities from a drop-down list of options. Select the collection data source as the type. Select customer as the entity. Set the ID to all customers DS. Open the Layout tab. Select Field Group Component. Open Properties panel. Click the Edit button to edit fields. Select the customer field and specify all customers DS as the option data source value. Click OK to save the field. Click OK to save the screen. Let's reopen the Order Edit screen to see our changes. Now we can select a customer using a drop-down menu. Now let's see how standard actions can be fine-tuned and what opportunities we have to define new ones. Open Shop Customers screen. Click Create. For now, Edit screen is opened in a current tab. Let's see how this behavior can be changed. Go to the Studio. Select Customer Browser.xml file in the Generic UI section. Click the IDEA button. We have two options to change open type for actions. First, we can define the open type attribute declaratively in the screen descriptor. Let's add the open type attribute to the create action with the dialog value. The second way is changing open type programmatically. Go to the screen controller. Inject edit action. Override the init method and add the following code. Let's see how it works. Go to the application, reopen Customer Browser, click Create. Now we see that the editor is open in a dialog mode. Click Cancel. Select any customer and click Edit. The editor screen also is opened in dialog mode. Let's see what other opportunities we have while working with actions. Go to the screen controller. In addition to OpenType, we can define captions, descriptions, icons, shortcuts, and many other options. Other useful things that we can define for standard actions are handlers. For example, before action performed handler, after commit handler, after Windows closed handler. Let's add a notification after customer editing. Add the following code. Reopen the customer browser and edit any customer. Now we see notification that the customer has been edited. In addition to standard action, we can define new ones, programmatically by extending one of the standard action or declaratively right in the screen descriptor. Let's define a new action declaratively. Go to the screen descriptor, add a new action element to the table's action. Set ID to send email. So imagine that we want to send some advertisement to our customers. Set caption to send email. Set icon. Set invoke to send email. We don't have such method yet, so press Alt-Enter to choose Add method. Now we need to add a button corresponding to the newly defined action. Add a new button element to the table's button panel. Set ID to send email btn. And set action to customers table.sendEmail. Now let's implement the sendEmail method. Control-click on the method name, inject customers table, and add the following code. Let's see how it works. Reopen customer browser, select any customer, click Send Email. So email has been successfully sent. Notice that the Send Email button is always available, and if we click on the button until no customer is selected, we get an exception. I suppose that it would be very convenient if this button checked if any customer is selected, like Remove or Edit button. Go to the screen descriptor. Add the Check Selection to True attribute to the Send Email action. Reopen the customer browser to see the changes. So the Send Email button is available only if any customer is selected. Let's take a look at the rules of layout. The basic component dimensions are width and height. There are three size types: content-dependent or auto size. In this case, the component will take enough space to fit its content. For example, for label, the size is defined by the text length. For container, the size is defined by the sum of all component size within a container. Components with content-dependent size will adjust their dimensions during screen layout initialization or when the content size is changed. Fixed size in pixels. Fixed size implies that the component dimensions will not change at runtime. Relative size indicates the percentage of available space that will be occupied by the component. Components with relative size will react to change in the amount of their available space and adjust their actual size on the screen. Container specifics. By default, containers without the expand attribute provide equal space for all nested components. Exception is CSS layout, Flowbox, and HTML box. Components and containers, width and height, are content dependent by default. Some containers have different default dimensions. The root layout element is a vertical container, VBox, which has 100% width and height. Tabs within a tab sheet are VBox containers. GrooveBox component contains a VBox or an HBox, depending on the orientation property value. So let's see some examples of what we have talked about. Equal size. In this example, we see that the container provides equal space for components. We have the VBox and the two buttons within, and each button has the same space within the container. Content-based size. In this example, we have the VBox without auto size for both height and width. As you can see, the VBox has 100% width and content-based height, enough to display two buttons within it. Relative size. Here we can see that layout as well as VBox or HBox provides equal space to all nested components. GrooveBox has 100% height. In addition to that, GrooveBox has 100% width and by default, and takes all the available space. Expand. The container's expand attributes allows specifying the component that will be given maximum available space. The component specified in expand will have 100% size in the direction of the component expansion, vertically for VBox, horizontally for HBox. When container size is changed, the component will change its size accordingly. In this example, the GrooveBox is expanded vertically. Form. In this example, the auxiliary label element is used. Due to applied expand, it takes all the space left in the container. So text field located at the top and buttons at the bottom. Margin. The margin attributes enable setting margin between container borders and nested components. If margin is set to true, the margin is applied to all sides of the container. Margins can be also set for each individual side: top, right, bottom, left. Here the example of top margin. Spacing. The spacing attribute indicates whether the space should be added between nested components in the direction of the container expansion. Aligning. The align attribute is used to align components within a container. Here we can see the label which is located in the center of the container. Component with specified alignment should not have 100% size in alignment direction. The container should provide more space than required by the component. The component will be aligned within available space. Now let's move on to some common mistakes while developing UI. Relative size. One of the most common mistakes is setting relative size for a component within a container with content-based size. In this example, the label has 100% height, while the default height of VBox is auto, that is content-based. Here, expand implicitly set relative 100% height for the label, which is not correct, just like in an example above. In such cases, the screen may not look as expected. Some components may disappear or have zero size. If you encounter any layout problems, check that relative size is specified correctly first of all. Also, CUBA has a built-in mechanism to validate the correct implementation of the layout at runtime, Layout Analyzer. Right-click the tab caption and select Analyze Layout. The current view of the screen has been checked for standard errors and they are displayed in the list. Aligning. In this example, the HBox has content-dependent size, therefore the label alignment has no effect. It is important to remember that layout errors do not always cause issues with displaying the screen in the browser, but they may lead to issues with making changes to the screen later. This is why they must be corrected even if the screen looks okay. Our next topic is data validation. Data validation is a common task that occurs in all layers of an application. Let us talk about validation options available in the platform. First of all, this is a field validator interface. Then this is a bin validation. And the third approach of validation is post-validate method. First of all, fields can be assigned a validator, a class implementing field.validator interface. The validator limits user input in addition to what is already done by the data type. Let's assign a validator to the customer's email field. Open the generic UI section, select Customer Edit XML, click the Idea button, go to the Idea. Inside the Customer Edit XML, add to the email field the nested component validator and add the class email validator. Let's see how our changes work. Go to the application, open Shop Customer screen, click Create. Type some random symbols in the email field. Click OK. We see the default error message that we set invalid value to the email field. The second approach of validation is bin validation. Bin validation is an optional mechanism that provides uniform validation of data on the middleware in the generic UI and REST API. Let's add bin validation for the quantity attribute of the order line entity. Go to the Studio, open the Data Model section. Select the order line entity, click Edit. Select the quantity attribute. Here we can see the list of available validations. Click Not Set button opposite the decimal max validation, tick Enabled, set value to 20. Optionally, you can define error message. Click OK. Click Not Set button opposite the decimal mean validation, tick Enabled, set value to 1, click OK. Go to the Source tab. Here you can see two annotations added to the quantity attribute. Generic UI components connected to a data source get an instance of bin validation to check the field value. The validator is invoked from the component.validatable.validate method implemented by the visual component and can throw the composite validation exception that contains the set of violations. Let's see how this works. Restart the application, open Orders screen, select any order and click Edit. Click Create a new line, set quantity value to 0 and click OK. We see the default error message that we set invalid value of the quantity field. The third approach of validation is post-validate method. Post-validate method is a template method that can be implemented in the controller for addition screen validation. The method stores validation errors information in validation errors object, which is passed to it. Afterwards, this information is displayed together with the errors of standard validation. Let's see how it works. Open the generic UI section, select Product Edit XML file, click the Idea button, go to the Idea, and switch to the controller. And we need to add the following code. Go to the application, open the product screen, select any product and click Edit. Set price value to 0 and click OK. We see that define errors message that we set invalid value to the price field. If you have any questions, feel free to post questions on our forum page and be sure you soon get an answer. Thanks for watching.